Hello students, my name is Jesse George, your professional accounting teacher. Before you continue with this video, please subscribe to my YouTube channel, The Georgian Theory Concept. Thank you. All right, let's get started. We are going to continue from where we stopped. So it is pertinent you watch the last video before you continue with this video, okay? Now we have solved from here to, I think, to this point where we are asked to calculate the degree of relationship. Then I taught you how to calculate R. That is the correlation. When you see degree of relationship, it means to calculate the correlation, like what you have said. Now, but look at this question. The question says, determine the correlation coefficient between y and x1, keeping x2 constant. So when you see a statement like this, we are to calculate the partial correlation. So it's talking about partial correlation. So in this video, we are going to bring conclusion to this question. So on a quick one, what is partial correlation? Partial correlation shows the relationship between the independent variables and dependent variable, keeping other variable constants. All right, class. So what it means is this. When you have a regression line, a plus b1 x plus b2 x2 plus c. Okay. Now, partial correlation says we should correlate, that is, find the relationship between y and x1, keeping x2 constants. Now, in order to find partial correlation, we make use of this model. So you have y x1 keeping x2 constants, okay? And the model is nothing but the correlation between y x1 minus the correlation of y x2, okay? Dot means multiply. Correlation of x1 x2, then the denominator will be the square root of, you open a big bracket, 1 minus, just bring this here, we have correlation of y x2, then close this, raised to power 2, 1 minus r correlation of x1 x2 in bracket raised to power 2, then. So this is the model to be adopted, all right? Anytime you are asked to find partial correlation, okay? Correlation between y and x1, holding x2 constants or keeping x2 constant. And you have been given the value of yx1. So this is yx1, yx2, and x1, y2. So I've taught you, we've seen how to calculate correlation using our calculator. So what we need to do is to substitute this figure in our. So I will start correlation of y x1 keeping x2 constant will be, so what do you have here? This is the value, you now have 0.2146 minus yx2, which is this value, okay? Which is this value. So what do you have? That is 0.1597, then multiply by the value of this, that is 0.5229, divided by, you will see it is advisable to use 4 decimal places, take note. Then you take the square roots, you open a bracket, 1 minus, just bring this value here, 1597 raised to power 2, 1 minus, bring this value, 0.5229. Sorry for this naughty mistake, raised to power 2, okay? Having done that, then our final figure from my calculator is 0.6. All right. So once you get your 6, and this is a positive figure, when you manipulate this with your calculator, at this level, students should be able to manipulate this with a calculator. Now, we know that our Y represents client's satisfaction. Okay? Our X1 represents effects of attitude. Then our x2 represents information. All right. Now we have a information system. Then the correlation. Now, how do you interpret this result? The correlation between the effect of attitude, and that is our x1, and client satisfaction denoted by y, holding information system constant. Information is x2, is positively weak. Okay, because r is equals to, is less than 1, is positively weak because our r is less than 1. Okay, less than 1. Are you with me? Which is this figure. So based on this figure, if your figure is less than 0.5, and if you look at this, it's less than 0.5, so you say the correlation between them is weak positive correlation, or positively weak. All right, it's positively weak. Hope that is clear. Yeah. Then the next aspect is to determine the significance difference between x1 and y1. All right. So when you see a question on this, this talks about significant difference between variables. Okay. In this case, you are going to form an hypothesis testing. Okay. Hypothesis testing. So to form the hypothesis testing, you will follow these steps. So look at the steps to be followed. I'm going to explain it. To determine whether to accept the null hypothesis or alternative hypothesis. Now, if a question says, determine the significance difference, between two variables. So in this case, we are looking at x1 and y1. All right. So you are going to form your hypothesis in this manner. So you will tell us, this is the solution to the question. Hypothesis. That's number one, is to form hypothesis. Write it down. You form hypothesis. That's number one. HO. What is our HO? That x1 is equal to y1. This means there is no difference. That is our hypothesis. That is the null hypothesis. Now, the alternative to this is denoted by h1 sub 1. It means x1 is not equals to y. This means there is difference. All right. This means there is difference between them. Why? This means no difference between these two variables. Hope that is clear. This is the first thing. You formulate hypothesis. The next thing is to calculate. You calculate the test statistics. Calculate the test stats. Okay? Test statistics. So in this case, we are going to use a model. You are going to use a model to calculate our test statistics, and it is called the t-test statistics. T-test statistics, write it down. T-test statistics is used where the sample is less than 30, is 30 or equals to 30, less than 30, okay? When your sample is less than 30, we use the t-test statistics. So examples of t-test statistics, we have the t-test score, the t-score, okay? But if your sample is more than 30, we use the z-score. So I'm going to discuss that later. But here we want to use the t-test, our test statistics. So we are using the t-test statistics, t-test. And the formula for this is, look at the model. This is the model, okay? This is bar, that is x bar, the mean of x data, the data for x. This is the mean, and this has been calculated before. The y bar is the mean of the y values, okay? This is the number of observation for x. This one too is the number of observation for y. Students will take note of that. Number of observation, what do I mean by that? You will see that we have 9 observations. If you count this, it's 9. For y, it's also 9. All right? Okay? So you are going to find the mean, and this mean using your calculator, we've done that before. And this is 3.5, okay? Then for y is 4.0, write it down. Okay, it has been calculated before. Even the standard deviation, because we are going to make use of. So they both have the same standard deviations, okay? All right. So as you can see, the mean is given the, okay, from the previous solution. Then our standard deviation, because we are going to need the standard deviation. Now, the standard deviation is the same, but eventually is the same for S1 is 0.55. For S2 is also 0.55, okay? Now, our SP is stands for sample pool. Now, you need to calculate this sample pool first before you now substitute in this formula. And the sample pool is given as nothing but open bracket n1 minus 1, then standard deviation x, that's raised to power 2, plus open bracket n1 n2 minus 1, standard deviation raised to power 2, all over n1 plus n2 minus 2. This is called degree of freedom. The denominator here is known as degree of freedom. So when you slot in n, so our sample pool, we need to calculate that. So from my calculator, I'm having 0.55. At this level, you should be able to manipulate this. So you can try it. If the answer is the same, you can make comments. If otherwise, you let me know in my comment section. Okay, now we need to substitute this in this figure. So we have our test, t-test statistics, okay? That's the calculated figure. Our x bar is nothing but 3.5 minus 4.02 divided by the sample mean 55. Okay, open a brick bracket, the square root of 1 all over 9 plus 1 all over 9. Okay, now when you manipulate this, you are going to have our t-tests. Our t-tests will be equals to, so this is the value of our t-test minus 8.864. You can approximate it to be minus 8.86. All right. Now, what do you do with this figure? So the first step, like I told you, is to formulate your hypothesis testing. X equals to y. That is no difference between these two figures. Then alternative is x, there is difference. We just have, so this one is to tell you when you have a symbol like this, is to denote two-tailed tests. Is denoting two-tailed tests. At 5 significant level, now you have calculated your t-test. You now compare. So the next thing is to compare. Now I'm going to give you a simple analysis here. All right. From the t-table, write it down. From the t-table, t-table, determine the critical value. Determine the critical value. That's what we call critical value. Critical value. If I were you, I will use what we call Gaussian curve. That's the normal distribution curve. We call it the Gaussian curve. So this curve is called the Gaussian curve or the normal distribution curve. All right. So I'm going to determine my critical value. So to determine this, you use the table, t-table. So I have a t-table here. All right. Now my degree of freedom here is 16. So when you calculate 9 plus 9 minus 2, it's going to give you 16. Okay. So I will go to where I have 16. This is where I have 16. I will count 1, 2. So this is degree of freedom and this is 16. Then if at 5 significant level, now determine the critical value at 5% significant level. Okay, this is the standard. If the question, you know that the question did not give you, but being a management science student, you make use of 5% unless it is stated otherwise. Where it is not stated, it is advisable to always use 5%. So the degree of freedom is 16. My degree of freedom is 16. Okay, so if it is 16, we use this normal distribution curve, or what we call the Gaussian curve. The Gaussian curve. You know, it was introduced by Gauss, a mathematician. So this will really help you. Now, this value, the intersection of the row and column. So the intersection of the row and column here gives me 2.12. So I'm going to have on both sides, if you look at this very well, this is 2.12. So you put minus here. This is 0. All the figures on the left hand side, they are 0. So if I have my 1 here, so my 2.12, okay, then this is the critical value. That's the critical value. This is the critical value, which is 2.12, because this is a two-tailed test. So you are going to have something like this. This is a two-tailed test. So in my subsequent video, I will teach you one-tailed test. But this question talks about two-tailed test. So let's base on that. So this is the critical value. The shaded region here is called the rejection region. Rejection region. This is called rejection region. Rejection. Then the unshaded here is called the acceptance region. What are you accepting? You are accepting the null hypothesis. Acceptance. You accept the null hypothesis. You reject the null hypothesis. Don't take note of that. So when you reject the null hypothesis, it means you are accepting the alternative. When you accept the null hypothesis, it means you are rejecting the alternative. When I reject, don't forget, if I reject the HO, it means I'm accepting the H1. And don't forget that you have already stated here that there is no difference, okay, between X1 and Y. But the alternative says there is difference. Now, you will compare this figure. Look at this figure now. You will take the calculated figure. What is the calculated figure? The calculated figure is negative. Are you there? Now, if you look at this figure, see how you do it. This is 0, okay? From here, we have -1. Between -1 and -2, which one is greater? Okay, it's -1. Now, between -1 and the calculated figure, which one is greater? You will see that -8 will fall around here. -8 will come here. It means it has entered the rejection region. So if the critical value, look at the critical value, all right, is now greater than -8, you will reject the null hypothesis. Class, when you have -2 is greater than -8. Take note of that. Even if you are considering the positive, all right, if you are considering the positive, you will see that 8 here will now be the opposite. 8 is greater than 2.1. Okay, so it will still fall on the rejection region. That's why it is two-tailed test. If it is less than, it will fall here. It means there is no difference. Now, it means you have to reject the null hypothesis. So you now write, since the critical value, that is the table value, that's what we call the critical value, is greater than the calculated value. Are you with me now? The table value, look at the table value, is greater than the calculated value. This is the calculated value, which is -8.8. You understand now? We therefore, therefore rejects the null hypothesis. Okay, that is HO, which means that this implies that this implies that there is a difference. There is a difference between between client's satisfaction. That is why client satisfaction and effects of attitude. Effect of, that is, there is a significant difference. Don't forget, there is a significant difference. Write it down. Effect of attitude. There is a significant difference between them. Attitude. Okay. All right, class. This implies that there is a significant difference. You understand? So, because from there is significant difference. That it means we have to reject this. So we are rejecting this, that there is no significant difference. But here there is a significant difference. So the use of this bell, the Gaussian bell or the normal distribution bell will always help you to make your decision. Okay? Because your T statistics falls within this region. All right. But if it falls within this region, okay, we will accept there is no difference. Thanks for watching. So if you understand this video, please do share with your friends. Thank you. Bye for now.